It is not so easy when you have to do this without notes, which you will tomorrow. So here we go. Name the function. What name did you give this, Jordan? Cubing. So we write cubing. We could write cubic. We could even write cube. Any of those are okay. Something with the idea of C-U-B-E. Okay? What did you write for this one? Greatest integer. Now, if you write integer, you do not get full credit. You have to write greatest integer.
Can we write GIS?
No, write the name. I don't call you EH, I call you Erica, right? Let's write the name. All right, what's this one? Logistic. And if you write log, I will mark it wrong. It's logistic. All right. Write the equation. This is a little harder now. First, you have to identify that. What picture is that? That's your natural log. So you either write y equals ln x, or if you want to write log x, that's okay, because it's your logarithmic picture. Okay? Everybody good? What's this one? That's your exponential, so its equation is y equals d to the x. And what's this one? Reciprocal, so y equals 1 over x. Perfect. Anybody have a question about those? Now you got to draw your own pictures. I need a little more room. So are we okay with the top ones? Can I erase all this up here now? Erase good? All right, now we're going to draw these pictures. All right, so here we go. Sine x. You know what I'm looking for. I'm looking for hills and valleys, right? Squiggly line. But what am I zeroing right in on? You are starting your hill right there. So I am looking for this shape. Look at that carefully. Make sure that's what you have on your paper. That's the sine curve. How does a square root look? It starts at the origin too. And just goes like that. How does this one look? Yes, it's a U. Let's call it a parabola. It's a parabola, right? Any question about that? The graphs.
On the test tomorrow, will it be like the square root of x plus 1?
No. Tomorrow's just BFFs. Now, we are going to have to do that on our test, and we're going to practice a little bit today. But tomorrow, it's just the straight BFFs. All right? Now, I've done 9 functions. Between naming them, writing the equations, and graphing them, I had 9. There's 3 left that we haven't talked about today. What are the 3? What's one of the 3 that's left? Cosine. So you either write the equation, the name, or you draw the picture, whatever you're most comfortable with, and that's what you get to do tomorrow. For the extras, the extra 3, you get to pick which way you want to do it. All right, cosine. What else is left? Absolute value. So you either write the equation, you write the name, or you draw the picture, which is what? A V. And what's the last one? The identity. So with that one, you can write identity, or you can write linear. Either one, because it's a line. It's the line. The equation or the picture. Is there anybody that got everything right without looking at notes? That's great. Tomorrow, let's all be ready to say that, okay? All right. Okay, let's start. We've got some practice tests we're going to start reviewing today. But let's start by making sure our homework is under control. Did anybody have a question about one of your 1.4 homework problems?
We did an example of the last one of the last few problems. 37 to 39.
Like 37?
One of them.
Okay, we did these yesterday, Jamal. It says find the implicit functions and x squared plus y squared equals 25. Who remembers, that was yesterday's lesson, who remembers how we find the implicit functions for something like x squared plus y squared equals 25? We solve for y. Remember, Jamal? We're going to get y by itself. So first I'll subtract x squared. And then I take the square root. So my two implicit functions are the square root of 25 minus x squared and the negative square root of 25 minus x squared. Remember doing that yesterday?
Yeah, no, I just didn't know the name.
Yep, they're called implicit functions, defined implicitly.
So if we put negative x squared plus 25, it's still good.
All right, who else had a question about one of the homework problems from 1.4? Either assignment, you had a couple different assignments. Taylor?
Can you please do 17?
17. F of x equals x squared minus 2. And g of x equals 1, not 1 over, just the square root of x plus 1. And I am supposed to find the compositions. All right? This means f of g of x. What do I know about g of x? What does g of x equal? The square root of x plus 1. And when we say we're going to find f of something, that means we take the something and plug it in for the x, right? So if this said, Taylor, if this said find f of 2, I would put 2 in right there. If it said find f of t, I would put t in right there. Well, it says find f of that. So I'm going to put that in there. So I'm going to have the square root of x plus 1 squared minus 2. What's the square root of x plus 1 squared? X plus 1 minus 2. So your answer is just x minus 1. Now, it's actually a two-part problem. The other part said do the same thing, but in the other order. So f of x is right here. That's f of x. Now we're going to take this and plug it into g of that. So we're going to plug that into the g function. So we have the square root of x squared minus 2 plus 1, or the square root of x squared minus 1. And are we going to take the square root of those individual pieces that are connected with a subtraction? No, never. That's just your answer. Okay? Once you got to pass. All right. We reviewed O'Connor's quiz, so you might want to watch the video to make sure you get that. All right, everybody. Let's get out our practice test and start in on that. much I get done will not be homework. Now, I've asked you to do this on a separate sheet of paper, so I need you to get out a piece of paper to go with the practice test. I can serve copies this time. For the first two, the third one I made big, but we're going to do this on other paper. So please get out a sheet of notebook paper. Everybody, this is your homework. We're getting started together. We might have it all done. Shouldn't take too long. Are we ready? Practice test 1 with a heart on it. Because I love you. We're doing this on another piece of paper. Here we go. Number 1, A. What's the domain? Okay, wait, this has a radical, doesn't it? Zach Bond, what do I know about radicals? Okay.
No, it's like not equal to 0.
Careful. Whatever is under the radical has to be bigger than or equal to 0. So x minus 3 is under the radical. So x will be bigger than or equal to 3. That's our domain. Zach's going to review his rules. So are the rest of you if you have forgotten. Whatever is under the radical is bigger than or equal to 0. All right, what about B? Tough problem. We have another radical, don't we? And a denominator, one at a time. Let's deal with the radical, since we just practiced. What do I know about x plus 1? It's got to be bigger than or equal to 0, which means x has to be bigger than or equal to -1. That's part 1. But this has a fraction in it, doesn't it? So what do we know about denominators? They can't equal 0. So x minus 2 cannot be 0, which means x cannot be 2. That's a 2-part answer. Why is it 2 parts? Because it has a radical and a denominator. C. All reals. Very good, Savannah. Thank you. And why is C all reals? No fraction, no radical. How about D? Now wait, time out. Is the 3x plus 1 involved in this discussion? No. It's not under a radical and it's not in the denominator, so it's not part of the conversation. What is part of the conversation? X plus 6 has to be bigger than, excuse me, x plus 6 cannot be 0, which means x cannot be -6. Does anyone have a question about any of that? 2, Jamal, this is your question. Find the implicit functions for this. Sure. Jamal's going to do this, but you do it on your paper. Now let's see if you guys can come up with the same answers. my job. He did this very nicely. So let's run through the steps to make sure everybody's with us. Jamal subtracted x squared from both sides. You okay with that move? Now, he's got a negative on that y squared that can't be there, so he divided by a negative. He divided this by a negative and this by a negative. Then he took the square root of both sides and wrote y equals the positive square root and y equals the negative square root. Beautifully done. Does anybody have a question about that? Remember, if these are on the practice test, they're on the test, right? So you have to be able to do this. Is everybody okay with that?
Yes.
Good deal. All right, part 3, horizontal, vertical, and holes. All right, so here we go with problem A. Now, let's make a little cheat sheet over here to the side. Yeah, Nathaniel?
I have a question on the last one. Why is it plus or minus?
Every time you take the square root, when you take the square root, you got to put in a plus or minus.
Okay.
This thing right here is a hyperbola. Okay, it's going to look like this. That is not a function. So in order to graph it on my calculator, I have to break it up into the top half of the picture, which would be the positive radical, and then the bottom half of the picture, which is the negative radical. And when I put those two together, I get the whole picture.
Okay.
Okay? It's always going to be plus or minus. Always. Okay. Now let's make it, like I said, let's make a little cheat sheet over here to remind ourselves. How do we get vertical asymptotes? How do we get vertical asymptotes? Where do they come from? From the what?
Bottom.
Bottom. The denominator can't be 0, right? So they come from where the denominator is 0. So take a look at this and tell me, where's my vertical asymptote? Where is it, Lauren? -1, where x equals -1. X equals -1. That's my vertical asymptote. Now, where's my horizontal asymptote come from? Okay, it comes from here. How do I describe that? Comparing x's on top and bottom. So my horizontal asymptote is y equals 3. You do. These are equations. They have to have letters attached to them. And then where do holes come from? You have to factor and cancel. That's the key. In this problem, is anything going to factor and cancel? No. So this one has no holes. Holes only happen if you can factor and cancel.
What's the X hole again?
Huh?
I'm saying, what is the, I'm saying, like, how do you do it again with X holes?
To get a hold, you have to be able to factor and cancel.
I mean, what would it be if
Okay, let's work on to the next problem, Moses, and we'll find one where it happens.
So why did you subtract the 3x and the x?
Why did I
Since you're
what?
like the 3x and the x.
I didn't subtract them, I canceled. I had 3x. What's 3x over x? 3. That's how that
So there's a
happened.
2 and there'd be 3 times.
Yep.
Okay.
Yep.
Let's see.
All right, here we go. Let's look at the next one. Is there anything that will factor and cancel? Well, we can factor in the top, can't we? But is it gonna do me any good? You still can't cancel, which means there are no holes. Is there anything that would make the denominator 0? -5. So your vertical asymptote is x equals -5. Uh-oh, this is one of the tricky ones. Because when I compare the x's on the top and the bottom, what do I notice? There's more on top. And what's the rule? When there's more x's on top, there's no horizontal asymptote. Remember, when the big X is on the top, there's no horizontal asymptote. If the big X is on the bottom, then it's Y equals 0. Moses and Zach, are you guys paying attention to these rules?
That's Jordan, but yeah, yes, ma'am.
Katie?
It was like 3x over 6x, would it be like 1/2?
Yes, it would be. If they were both X's, yes. So 3x over 6x would be 1/2.
Okay.
Yep.
So it's only like,
Good?
Yeah.
All right, and then the last one. Moses, pay attention to this. This is going to answer your question now, okay? So here we go. All right, take a look at this problem. Why don't we try to factor it? Look at the numerator. What can I factor? Take out a 3? Can I do anything else to it?
X plus 9, X minus 9.
What would it be?
X plus 9, X minus 9.
X minus 3, X plus 3? Actually, it's not close enough. So that's my numerator. What about my denominator? What can I do with my denominator?
Minus 3, minus 1.
That's close enough. Now, what do we notice? Cancel. So our problem has been reduced to this. This is what's left. Because we canceled, this time we are going to have a hole. You guys, a hole is like a point, okay? It's an open point. So it has an X and a Y. The X comes from what you canceled. It's the opposite. So since I canceled X minus 3, my X value of my hole will be positive 3. What is the opposite of what you canceled? So if you had a problem where you canceled out an X plus 2, it would be at -2. Now that's only half the answer though, because you still need a Y coordinate. Here's your equation. Y equals this, right? So how am I going to get Y? I'm going to plug in 3. I'm going to plug that 3 in right here, and that's going to give me Y. So I have 3 times 6 over 2. Put a 3 here, and I got 6. Put a 3 here, and I got 2. So what have I got? 9. So my hole is at 3, 9.
By whole, like, does that mean it just doesn't exist? Is it like,
It just means that when you draw, whatever picture you draw, it's gonna skip over that point.
oh, like why?
Why is it skipping over that point?
Yeah.
Because in the original problem, if you put 3 in, you have 9 minus 12 plus 3, that's 0. You can't have a 0 in the denominator. However, so that means it's an undefined value. That means you can't use that point. However, there's 2 ways to be undefined. You can be undefined and cancel out, or you can be like this, where we just say x can't be 1. Your vertical asymptote is x equals 1. You cannot put 1 into this equation. That is more powerful. That actually splits the graph in half. This one, you can't have 3, but you just kind of skip over it. You don't like actually break the graph in asymptote. This, when the denominator is 0, you have a problem. You can either cancel out the problem and have a hole, or you cannot cancel out the problem and have a vertical asymptote. All right, so everybody okay with the vertical asymptote of 1? Yes. Jordan? With what part? Okay, I got, when I cancel out, the opposite of what I cancel becomes my x coordinate. Jordan, that's x. So put it right here for x. So 3 plus 3 is 6, and 3 minus 1 is 2. Now what about a horizontal asymptote? You can either look at the original problem, or you can look here. Either way, where is your horizontal asymptote going to be? Y equals 3. The powers match, you guys. So it's just 3x over x, 3. Or 3x squared over x squared, 3. You okay with that? All right, part 4, this is the sketching part. And you'll notice that the first one is a piecewise. You will have to sketch a piecewise function on your test. Okay, which piece do you want to start with, top or bottom? Top? All right, we'll start with the top piece. What does that look like? Y equals 2x plus 1. Well, it's a line, and its y-intercept is where? At 1. And its slope is 2 over 1, so I'll go up 2 and over 1, up 2 and over 1, down 2 and over 1. So I'm going to try to graph that line straight. I'm just so bad at this. All right, there's my line. That's the top part of the picture. You are not allowed to be confused at this point, because you have been graphing lines since you were like in 7th grade. All this is a line. The slope, or excuse me, the y-intercept is 1, and the slope is 2. Now, I only want part of that line. Remember, this is the kind we have to erase part of it. Where is the break going to happen in the picture? At 2. So here's 2. I'm just going to put a dashed line there just to remind myself. There's 2. Where the line hits 2, I'm going to put an open dot. Now, why is the dot open?
Because it's not greater than.
Because it's not equal to. Now, that says greater than 2. Does greater than mean I keep the right part, or I keep the left part. Greater than means the right part. So all this gets erased. And there's the first piece of the picture. Now what does this look like? That's a V. You're not allowed to be confused by that either. That's one of your BFFs. That's memorized. Now where it hits my break, I'm going to put a solid dot this time, right? Would you agree with that? Now what am I going to keep? The left side of the picture or the right side of the picture? I'm going to keep the left, get rid of the right. Remember, you will always keep one left side and one right side. Never two lefts or two rights. Always one of each. That's it, we're done. With that one. Now, Erica, the next question is one like you were inquiring about. Because B says graph this. And C says this. And D says this. Now, if you know your stuff, you can whiz through these. What shape is that going to be? A V. And normally the V looks like that. But where's this one? Because of that, right, that's exactly right, Franny. We're going to pick that V up and move it 1, 2, 3 to the right. And that's all you have to do, is draw a V 3 steps to the right. This moves it 3 steps to the right. There's my sine curve, guys. What am I doing to my sine curve? Moving it which way? Down one. Down one. If I want to move it right or left, it would have to be in a parentheses. Remember? That's how you move it right or left. If it's just tacked on the end, that's up or down. So this goes down 1. I'll do the different color. So if I move everything down 1, I get this picture.
Wouldn't that make it cosine?
No, it would not make it a cosine. Now, if I shifted it sideways, I can make it a cosine. But no, this is still a sine curve. It's not passing through that point. No, it's a sine curve. All right, let's do this last couple here. What happens here? What shape is this one? This is D. What shape is D? It's a parabola. And normally that parabola would be sitting at the origin. Where is this one sitting? Left 1, down 2. So you're going to graph that parabola. Some of you have not learned your rules. Let's refresh those, because you're going to miss these if you don't have them. We have this, and we have this. We have this, and we have this. We can add and subtract Inside the parentheses or outside the parentheses? Inside the absolute value or outside the absolute value? If it's inside the parentheses, inside the absolute value, then it moves which way? Right or left? This one would go left 2. This one would go right 2. Inside the parentheses, left or right. Outside the parentheses is up and down. This one would go up 2, this one would go down 2. All right, we got through, let's finish part 4, then you won't have to worry about that. Part 4E. Okay, 4E is y equals x cubed plus 1. All right, everybody knows what x cubed looks like, right? What does a plus 1 in that position do? Takes it up 1, so it's going to pick up this picture, and instead of squiggling through the origin, it's going to squiggle through at 1. It's going to look like that. Picked up 1. And then we have y equals the square root of x minus 3 plus 2. Square root function looks like this. Now instead of starting at the origin though, we move. How did we move? Right 3 and up 2. So there it is. Right 3 and up 2. Your homework tonight is only part 5. That's all that's left. Now, obviously, if you want to do more,